Hi, and welcome to SPO 1324 update on Intel's newest technology offerings and innovations. My name is Christian Holsing. I work at Intel covering as a technical account manager our open source vendor partners, including SUSE. So, as always, the typical notices and disclaimers apply here for this presentation, and let's dive right into it. So when we look at our product portfolio, Intel has changed quite a bit over the last few years from standard CPU vendor to a slightly different approach that we're taking. And hopefully you will see this during the presentation that there is a bit of a change how we basically look at our silicon products and the supporting software around it, because in this world of very diverse workloads and requirements that they represent onto silicon, when we design a new chip and new products, we're really looking at the workloads and try to consider this. And you will see this in a variation of offerings that might be overwhelming initially, but I really want to give you a little bit of a insight of how to parse things and how to find good solutions and really understand a little bit better what we're doing and how the whole ecosystem is working, and tying it back to where I started, how the Intel offerings can help you to run your workloads more optimal. And I mean, part of this also is software, as we're in the context of Linux and open source ecosystem here. That's also very important, because just having a feature in hardware doesn't necessarily mean that from a software perspective, the operating system or your application is able to benefit from it. So there's a whole stack here that comes into play for really an application, for example, SAP, to benefit end to end throughout the whole stack, or even AI, where things might even be a little bit more complicated from the software ecosystem, APIs, and so on. So, having said that, let's take a look at the server product line first. And the latest product that we've brought to market earlier this year is the fourth generation Intel Xeon scalable processors, which really introduces as a server product the first workload first approach to really address different needs of customers. And we all see this, and I'm talking about this in the SAP session as well, that the drivers for IT projects are widely different. Some customers are looking at TCO reductions, whereas others are looking for platforms that they can get more performance out in the future. And this is really part of the drivers why we're looking at silicon solution at products this way. This results, and you might have heard about this, in a set of accelerators that are making it into the CPU at this point. We cover this in a bit more detail here. And really, the combination here helps us to bring the leading performance to the different industries, and give them the value they need. And one of the key innovations that we're looking at right now in the server context is confidential computing. So you've seen this probably also here at SUSECon from SUSE, that with a lot of workloads moving into the cloud, which means the CSP's data center, and regulations, especially in Europe, about data privacy and regulations around processing data that can be tied back to individuals, and the needs under GDPR. This is something where both SUSE and Intel believe there is a big market, and where we will see more demand to meet really the customer needs. Now, as I said before, Intel Xeon fourth generation, that's the latest server chip that we bring to market. And I don't want to take you through the whole slide deck here. That should be available afterwards, but just a set of key things to point out. So new PCIe standard 5.0 is supported. CXL stands for Compute Express Link. It's is supported on the fourth generation, and this is especially important if you look at it from, for example, an SAP context and the ability to address memory. So you might remember the persistent memory technology, and that was basically the idea of being able for an SAP database to just really store and store the database on a persistent memory, and having it as it was connected as DRAM into the system, really in a very fast access mode for the system. And you probably have heard that we can discontinued Optane memory. And CXL basically is what we're looking for, what the industry is looking for as an alternative here, because what CXL allows you to do is basically have very fast accessible memory attached via CXL into your server. And that is something that obviously SAP is looking into. It's not being certified, but these discussions are going on right now. And that will allow you to attach, besides regular DRAM, also different other storage technologies via CXL into your servers, and have those two kinds of memory supported, and being able to address larger memory footprints if that's a concern for your business. Yeah, again, we have various kinds of accelerators that you see listed here. One other notable thing here is also the move to DDR5, which gives you increased memory bandwidth and with that faster access. So that's all coming and is available right now to our customers and to the market. Now, talking about the accelerators and tying it back to where I started, the workload optimization. So when you look into these different areas of compute, AI, security, HPC, networking, they all have fairly different requirements. And some of the accelerators that we have, like AVX512, advanced vector extensions with 512 bits per instruction set, that really helps you to speed up the performance of matrix operations here, or with QAT having the ability to encrypt and decrypt data like SSL, TSL encrypted data much faster. AVX will also help you there. But that's really the idea, to move some of the algorithms, for example, into hardware, and with that speed them up and especially offload the CPU. I think that's the easiest way to explain it, that instead of having the CPU basically performing all the operations, the CPU hands off the encryption or decryption, if we use this easy example, to the accelerator engine, and it just simply returns the result to the CPU, and the CPU doesn't have to worry about the numerous steps here to perform the action. And as you can see, there are very different accelerators that the latest generation of Intel Xeon CPUs are providing. And of course, and we cover that later, there is also a software component here to enable it. And we're making really good progress working with our partner at SUSE together to really get the accelerators enabled in the operating system, and with that towards exposing it towards Kubernetes in the next step, so that the workloads that you're trying to run on top of the Intel Silicon family can actually take advantage and are able to speed up the processing time here, which, if you think about better TCO or more performance, will help you to achieve this. As I said before, there's also a set of development tools around that people can go to, that we make available. I cover OpenVINO a little later. There is one API, which is the intention. So that's basically the umbrella for a lot of Intel SDKs, including also compilers that basically make use of the additional um, accelerators on the chip in the best way. So that's something to look into. Of course, we also contribute these features and the enablement back to open source, and GCC will also see the ability to tap into the accelerators. So that's in parallel and dependent on your needs. You get different options to use different compilers and take advantage of the new features. So go to the Intel website and take a look at one API if you're interested. You will see a lot more sophisticated detail on our website. Just touching this a little bit, because that's just the logical next step if you think about the workload optimization or the workload focus in the different accelerators. There are different variations and different SKUs, different part numbers, dependent on the usage that you intend the CPU for. So there are cloud SKUs, there is a network SKU, because the network workload obviously has a very different characteristic and need compared to HPC, for example. And these different SKUs basically look at a potentially different set of accelerators. So, for example, there is a SKU called Sapphire Rapids EE, which is optimized for network workloads, and they have dedicated accelerators on board for random access network workloads in the telco industry. So really think about the Xeon processors as a foundation, and different variations here that, for example, if they are liquid cooled and if there might be industry usages, there is a different temperature requirement on the CPU. So the variations of CPUs are really focused on the usage, and what you see here is basically PV and M are the variations. So the code name for the fourth generation Xeon was Sapphire Rapids, the current generation. So there is the P, the V, and the M SKUs that are available for cloud usage, or the U SKU for one socket machine. So that's the way how to parse the information. So moving from server over to the desktop. So what you see in the desktop area is basically a move towards hybrid architectures. What hybrid architectures basically means is that on the current CPUs that we build and ship, almost all of them have so-called P and E cores. So the P cores are basically the power cores, and that's what you've been used to from the previous generations of the Pentium processors and the Intel Core processors, which had one type of cores. And the E cores is the efficiency cores, single threaded, so they don't support hyper-threading like the P cores, but they are actually more powerful for single threaded applications potentially. And the 13th generation, which is the generation that is shipping right now, usually has a combination of 2 or 4 P cores plus a set of E cores, and the operating system then determines, based on the scheduler algorithm, where to put an application or a specific thread, to be more specific. So that gives you a better performance, and there is balancing happening in the background. So it's quite interesting to see which strategies, which scheduling strategies we have implemented, and we're moving forward to really increase the performance and being able to understand a specific process and then assign it on the right type of core. Also here, and we've seen this for the Xeon CPUs before, we have different SKUs. So the S series is basically the desktop SKUs, and then we have the mobile series here, which have slightly different characteristics in terms of power consumptions and yeah, and so on. So little glimpse on that. And from a feature perspective, this is a slide on gaming. That's still one of the more demanding desktop usages that we see. But also over here, you see, for example, that PCIe 4 generation 4 is supported, USB 3.2. We see, as I was talking about the P&E cores before, we see up to 8 power and 16 efficiency SKUs on a 9.9 SKU. So it's really scaling up and out, and the CPUs become really, really powerful that way. And there are also other enhancements like Thunderbolt 4, Wi-Fi 6E, which is coming, which is supported, DDR5 support also here, so you get more speed on the memory. So really different things, different standards that the 13th generation of the Intel Core CPUs supports here for our customer base. Couple of facts. So like we got the benchmarks on I think Phoronix was doing some of the benchmarking here. So the i9 1390K is one of the fastest, definitely one of the fastest CPUs on the market. So 5.8 gigahertz for the power cores, with 24 and 32 E-cores, so 24 cores, 32 threads, and larger L2 caches. So that gives you really a huge boost in performance. So from the CPUs, let's take a quick jump over into NUCs. Which is the new design, not really new. We have this out in the market for a while. Next unit of computing, that's what NUC stands for. But it's basically an all-in-one box that Intel ships in various form factors, starting from a board over an integration unit that you can use, or just a very simple chassis with everything preloaded based on the 13th generation of the CPUs or the 12th generation of the CPUs. And we see a huge adoption here of the NUC technology. And if you find our friends at SUSE, there are also various customer projects where customers are taking NUC form factors to, for example, run a Kubernetes cluster on top of the machines and put them into the shop floor. So the NUCs are usually very cost efficient. They are very standardized in the components. And from that perspective, for these kind of use cases, a very good starting point to build from, and have a standardized computing unit, basically. So a business that Intel was starting to look into as well over the last 12 months is GPUs. And this is basically both server and client. So I was on the gaming before, so we're we're making gaming graphic cards available as well as server graphic cards. And obviously, if you think about the GPUs for more server usage, one of those is AIML use cases, no doubt about that. There's also cloud gaming that we're looking into, and these cards are becoming more and more powerful. So we entered the market. There are some good promotions around the cards, and you will see more and more coming in this area over the next couple of months, I assume. And as I was talking about AIML, there's also OpenVINO that's associated to it, which is our AIML solution and foundation. But before we go there, let's just take a look briefly at some of the highlights. So up to 256 tops here that you get as performance, 16 or 32 cores that the server cards provides AV1 encoding and decoding, super fast memory, optimized power consumption here, and hardware SRIOV, which becomes quite interesting. This is one of the use cases that I'm, for example, looking at right now. So the idea of SRIOV is basically having dedicated slices of the GPU assigned to virtual machines in the GPU case, so that, for example, if I'm running a classroom scenario, and I have the server rendering the graphic for a connected client, then SRIOV really helps you to basically assign dedicated slices and not having workloads interfere with each other. And that might also be the case for cloud gaming, obviously, because if I'm running multiple gaming sessions in parallel, I want to make sure that everybody gets the similar experience out of the GPU, and there's not one workload that's getting a better quality than the other one. So that's what SRIOV is doing, and there's also SRIOV for networking and other areas. Okay, so I was talking about AI already. So of course, and I said this multiple times, the solution is not only made up by just silicon. There's also software involved in it, and especially there's a lot of movement right now in the AI stack. Multiple frameworks are basically what is used in the market, like TensorFlow, PyTorch. And a lot of the machine learning algorithms just simply consolidate there. Where it's getting interesting is that with OpenVINO, we have, I think, a quite interesting approach that a developer can start to build in TensorFlow or PyTorch, and using it in conjunction with OpenVINO, which is provided and maintained by Intel. And what OpenVINO does is you basically take your TensorFlow or PyTorch model and you run it against OpenVINO, and based on the available hardware that your machine has, the model is not changing. But if there is only a GPU on the chip available, it would use this. If there is an Intel Arc graphic card available, and with that a graphics GPU, it would use the graphics GPU. So it's really based on the availability in the hardware that OpenVINO moves the model and the workload to the best available GPU. And as a developer, there is no need to rewrite the code, which means you can basically develop your model on your laptop and then move it to the cloud, and a dedicated system that runs the GPU. So that's really quite interesting here, and we're also looking into some conversion here to be able to import non-Intel models and also run them easily on on Intel technology, but you will find more details on that on the Intel website. Okay, so Linux enablement, of course, we're contributing a lot to the Linux kernel. So the enablement of the accelerators, the whole scheduling of the P&E cores on the desktop, the drivers for the GPUs, all of this is work that Intel software engineers are doing, and we are contributing them to the Linux Foundation so that they are making it into the upstream code. So that's business as usual. There is also a very close collaboration here with SUSE to basically look at the different areas in our portfolio from Intel and seeing what which drivers we should backport into SUSE Linux Enterprise, and where we have overlap, where we have customer needs. For example, in the telco space, if a customer wants to use the latest Intel NIC capabilities, then there is discussion, how can we take these drivers that are probably on a later kernel version, backport them into the kernel version that SUSE is using. So there's a lot of work that happens in this space, and where we have really ongoing discussions between two companies, and it's also going above and beyond the question of just driver and upstream work that we are doing. There is discussions on Trento, how to integrate hardware monitoring. There is discussion around the APIs that I was just referring to. There's optimization for the SUSE telco stack and the Sapphire EE SKUs that I was talking about before. So really a lot of discussions are happening in the background to really see how can we get Intel technology and this enablement through software into the SUSE products where it makes sense. So with that, there's then also a new offering that Intel has launched. If you're a developer and you want to try out the latest products that Intel brings to market, we've launched a developer cloud last year, and developers can sign up there, get access to, for example, the latest GPUs, the latest Xeon processors, to really try your code, optimize your code against the Intel products. And there is a huge overlap, and I should mention that as well, between the SUSE approach and the Intel approach. So both companies believe in an open ecosystem, and that's what we're doing. A lot of the Intel code, the Intel software, is also available on GitHub. Customers can try it out. It's open sourced. And we really want to give customers an open choice, and give them the benefit to develop once and then run it on multiple technologies at this point. And there's a lot through the Linux Foundation, also a lot of collaboration also with other silicon vendors to really see how can we unlock the potential of an open ecosystem. So again, Developer Cloud is available. You can check it out, create an account, and really get access to latest technology and try that out. And also you have access to learning resources this way that you can use. Okay, with that, I'm going to wrap up here. Thank you for your attention. Please feel free to find us during SUSECon on-site or reach out to us through the platform if you have any further questions. Thank you so much, and goodbye.